All right, welcome to another video. Fortunately, I got to start this video off with a little bit of maybe an extended monologue. I've been wanting to go with one topic a day, but I haven't been able to do that. So I'm gonna try. Let's see here. So this video, let's just keep things pretty streamlined because just the fact that I've got the camera rolling and stuff is already kind of a lot of progress. That's how it all starts. So never mind that. I'm actually not going to be having an extended monologue. We're just going to move right on. So last video, I went through a lab on BGP attributes. We looked at path selection. We looked at some reasons why a path wouldn't be selected, and we saw in various show commands some output that can be used to learn more information about why a particular path was selected over another one based on those attributes. So quick preview, I can open them again. We can do a quick preview on what those commands were. All four of those commands are going to be pretty essential. So the first command we learned was show BGP neighbor, the long form. Usually I just look at show BGP summary to get a sense of the neighbors, but this command, the long form of it, can be important because right here you can see NLRIs for which peer. So we're talking about the peer. This is the not the peer. This is the device here can receive multiple paths. So we can tell based on whether this is enabled or not, whether this one here can send multiple paths. Because if it can send it, then its peer can receive it. So that's an important one to learn. Then of course there's also commands that I already knew, but are always helpful to go over. So it's show route receive protocol, BGP neighbor, or BGP, and then you have to get the neighbor. You can't just look at it for all. So this one I already knew, but it's of course a very essential command, so it's always good to bring up again. And unfortunately, the syntax is a little strange because it's kind of different tenses. Okay, but yep, here's the command. And then we learned when you've got multiple hops, the way they're going to show up, or when you've got multiple paths, the way they're going to show up is through multiple hops. Okay, so that brings me to the last command that we learned more about in the last video, and that's show route detail. Okay, so what we learned in the last video is that there's a really useful piece of information that shows up in the long form of the commands, and that is, oh, and it's not going to be in the active route, of course. You've got to look at the inactive route, and it will give you an inactive reason, and this will be related to that, those BGP attributes. So not best in this group because of the router ID, and inactive reason as-path. So we can directly see which BGP attribute caused it to be an inactive route instead of the active route. Okay, so let's move on now. I marked that complete. So the next is going to be routing policy. I think this this lab is going to be fine, and I apologize, I was not sharing my screen for all of that, but I am now, so we can see the You can see my screen, so we can see that the next topic is going to be routing policy, specifically regexes. So I think that topology that we've already got from the last lab will be sufficient to learn about this. Okay, so we've got some good notes. Oh, yep, so we've got the notes. So let's find some good help documentation, either using Treasure Trove or just trying to use the the faster way. Let's try the faster way now, because if I can save myself from having to memorize the Treasure Trove script, I'm already kind of in a better situation than I would be otherwise. So I believe I had all of my yep, so I've already got my uploading complete from the other one. So let's do a rename just to get the string. So instead of path selection, we're going to be learning about routing policy. And we're going to be looking at regex. Oops, so I'm going to be doing the same thing, rename. Okay. Perfect. So we can add regex here. We can keep Python in there. Well, let's take it out for now until I actually use it. So yep, let's try to find some good help documentation. I'm not sure where this S came from at the beginning, but everything looks good here. So let's go to the lab. Okay, so a faster way, if I don't want to memorize the Treasure Trove script, I can just do HelpApropos and then a dot here so I get everything. And then I do want to do some filtering, but we're going to filter it down by help topic. Otherwise, it would show me all the show commands, everything like that. So we're going to need to do a keyword after the pipe, and the keyword is going to be match. Oops, and another thing is I can do set CLI screen length 0. Okay, and now when I sit down to take the test, this can be the first thing I do, and we're gonna try to see right now if this is going to be useful or if I really do need to memorize that Treasure Trove script, because what the Treasure Trove script will do is basically the same thing I'm doing now, except for it will filter the results down so that it will only give me back results that have the string example with a colon. So I find those pieces of documentation typically have better information in them than other ones. There's multiple pieces that just don't really have anything useful in them at all. And of course, there's some like help topic MPLS where you can't even run that command because you have to put a extra keyword after it. So my Treasure Trove script just digs in through all the commands here and pulls out the ones that are hopefully the most valuable. Okay, so the other thing that's going to be a lot better for me during the test is I won't be able to or is I'll have a much better terminal, so I won't have to just drag to highlight everything. But here we go. We've got just about 44,000 results. We've only got like 800 when I use the treasure trove, but let's see if this will work, because this is a lot faster than treasure trove. That's like probably 6 minutes or so. And then of course I got to memorize the script, but we're going to be learning about regexes. Here we go. So we've got lots of good. Oh, it looks like we've only got 2 results. So let's do a mark. So yeah, we've only got 2 results, and let's add those to our notes. Okay, I think this is going to be it pretty much. But take a look at these event scripts as well. Okay, so yep, I think that's everything. So let's start with the first one. Okay, so configuring AS path, regular expressions, perfect. This is exactly what I need to do. So let's try to implement this. So we're going to take a route that matches a particular AS path, and then we're going to modify the preference on it, and we're going to accept that route. So let's go back to the topology here. Let's go to router 8. Okay, and then let's do a show route protocol BGP. Okay, so now we can see we're learning this route. Now we do have 3 different routes for it, but you'll notice we do have an AS path here that's different than the other 2. So let's apply a routing policy to make a regular expression that matches for this AS path, and then makes this the preferred instead of this one here. Okay, so it's going to be edit policy. Wellington, that's interesting. Okay, let's go to the command line. First of all, let's just see if we can copy this word for word. So configure private, edit policy options, set Wellington. That's an interesting keyword. I've never seen that before. Yeah, and it doesn't autocomplete. So I'm not sure why they think you can just enter the word Wellington here. So I don't know what they mean by Wellington or by Addison here. I don't think that's valid syntax. Okay, so so it looks like I need to set an AS path. So let's do edit routing options, or let's do set. Oh, we gotta go to the top, set routing options. Now is there AS path? Set policy options. Here we go. So this is what they meant to say. They just forgot the key term as-path there. So if I do edit policy options, I can do set as-path. Okay, now is where I could name it Wellington. Yeah, let's just call it Wellington. Why not? Like the beef. Okay, so now we can do 2-2. So we should have only one matching that. So we've got our as-path that's named Wellington. So let's go into our policy statement within our policy options. And we'll say, we'll just call it from Wellington. The naming doesn't really matter too much. On the test, of course, I'm going to need to use naming that makes sense. The naming does matter because it's just a matter of how well you understand what's on there. You can really mess yourself up if you use naming that makes things more confusing. All right, so let's do set term 1 from as-path Wellington. Okay, and we'll do set term 1, then preference 200. So we're going to increase the preference of this route, and hopefully it will now become the active route. Let's do set term 1, then accept. Okay, and I like what they're doing here. This is normally implicit, but they're making it explicit by including the configuration. That's always the preferred way to do it. It looks like they're naming their terms a little bit different. They're calling this term term 2, and they called the other terms term 1. I'm just going to go with a number. I don't think term really helps, just including that. Okay, so we've got the configuration added. So let's commit it, and let's see if hopefully, well, we are going to need to apply it somewhere. So hopefully they give instructions for how to apply it. Oops, so there aren't any instructions for that. Let's just see ourselves if we can figure it out. Okay, so it's a little bit easier on here. I've only got one group. So let's go into the group RR. Okay, so I'm in the RR group. So let's see if we can do a, so I'm pretty sure it's going to be an import policy because it's from the perspective of the routing table. So we want to modify the routes as they're added to the table to increase the preference. So let's try that. We're going to do import Wellington or import from Wellington. Okay. Oops, so it looks like I already committed the other configuration. Yes, I did. So this is the only change I'm making now. Oh, great. So now let's go and see that it had picked the other route to be active. And there we go. We can see when I do show route protocol BGP, not only is this one active, it's now the only route that has been accepted, because if we take a look at the routing policy again, we can see that if it matches the AS path, which is 2.2, which we can see, yep, 2.2 is in there, it's going to accept it. But now this is a statement isn't entirely necessary because it's going to happen from by default, but we can see it's going to reject anything else. So if we go back up to the routes that were in there before, you can see they did not have that same, they do not match that regular expression. So they're not even going to be accepted into the routing table at all. Okay, so yeah, I feel pretty good about that. Might even end the video early. I just haven't been feeling super good the last few days. I think I'm going to start to feel better though pretty soon. So I can probably make up for the videos I missed on the weekends. If I'm feeling really good, I can do like 2 or 3 hour, 2-hour videos. No problem on the weekends. Okay, so yeah, I think I'm gonna end this one a little bit short. This is really all I need to have learned about. Yes, it's gonna get a lot crazier on the exam. It's not gonna be just a simple regex like I did, matching like 2-2. In fact, there's a good example. Let me close this and go over here. So yeah, here's a pretty good example of how complicated it can get during the exam. There is going to be a question that I would expect the answer would be this complicated. But I understand what all this means. So you're going to look for this match, and you want this match to occur any number of times 1 through 6. So you can have 1, 2, 3, 4, or you can have 1, 2, 3, 4, 1, 2, 3, 4, so on and so forth until the max you get is 4 iterations of that, or sorry, is 6 iterations of that. And then it has to have a space, and then you can have, then it's going to be 5, 6, or 4, 7, and it's a non-greedy match. Then you have to have another space, and then 78, 101, 102, and 0 or more times. And it's a, yep, so then it needs another space. And then it needs the number 9 at least once, but it can have it as many times as it shows up. So let's just put this in a, now I won't have this on the exam, but I find a regex chat tester is always really good to use whenever you have it, just because it will tell you in plain English what your regex means. So let's put that in there and then read the plain English version. And I think that might be it for today. I want to take another walk out back. Okay, so the plain English explanation is 1, 2, 3 matches the characters 1, 2, and 3 literally, case sensitive. 4 with a curly brace 1, 6 end curly brace matches the character 4 literally, case sensitive. So they're just talking about this section. So for this section here of the next part, it's a quantifier. It matches between 1 and 6 times, as many times as possible, giving back as needed. So it's a greedy match. It matches the character space literally. So let's see if we can come up with some strings that have a match. Okay, but for now, but we're going to need to finish the whole. So we can see we don't have a match now because it has matched these first part here, but it doesn't match the next part. So let's read about the next part. So this is in a capturing group. It's the first capturing group. And the capturing group has a quantifier, so it matches between 0 and 1 times, as many times as possible, giving back as needed. So it's got two alternatives. The first alternative is 5, 6, and it matches the characters 5, 6 literally. So let's add that in there. Okay. The second alternative is 4, 7, matches the characters 4, 7 literally, matches the character space literally. Okay, now we've got another capturing group, and we've got a different quantifier than we had before. Before we had a question mark, here we've got a asterisk. So an asterisk matches between 0 and unlimited times, as many times as possible, giving back as needed, greedy. That's different than the question mark, which matches between 0 and 1 times, as many times as possible, giving back as needed. So this is between 0 and unlimited. A repeated capturing group will only capture the last iteration. Put a capturing group around the repeated group to capture all iterations, or use a non-capturing group instead if you're not interested in the data. So we've got 3 alternatives in this one instead of just 2 in this one. The first alternative is 78. 78 matches the characters 78 literally, case sensitive. Second alternative is 101. 101 matches the characters 108 literally, case sensitive. Third alternative is 112. 112 matches the characters 112 literally, case sensitive. All right, so let's pick one. Let's go with 101. Okay, so now we've only got the last part. So it looks like it ran off the screen a bit. Let's see if we can make this bigger to see. Oops, so it looks like I might have, yeah, I don't have the whole expression there. So yep, it looks like I cut off the final plus sign. All right. So the final part here, 9 plus, matches the 9 character literally, and it's case sensitive. It's got a quantifier. Now this is a brand new quantifier. We had the question mark and the asterisk as a quantifier before, but now we have a different quantifier, the plus sign, and that matches between 1 and unlimited times, as many times as possible, giving back as needed. So that's different than the quantifier of a 0, because this matches between 0 and 1 times, as many times as possible, giving back as needed. It's different from the asterisk, because this matches between 0 and unlimited times, as many times as needed. So here is 0 and 1, here is 0 and unlimited, and this final one is 1 and unlimited. So they're all different. As many times as possible, giving back as needed. So this character here, again, is 0 and 1 matches. This is 0 and unlimited matches, and this is 1 and unlimited matches. Global pattern flags. G modifier, global, all matches don't return after most match. So these are just the default global modifier flags. Then we've got end modifier, multi-line causes begins with and ends with symbols to match the begin and end of line, not only begin and end of string. And those are the default modifiers. You can change those. If you've got a multi-line string, you can have these match just the beginning of that whole string or the end and not be dependent on what line it is on. So let's see if we can get a full match. There we go. We've got a full match, and we've got 3 matching groups. So in group 1, we've got everything there. Group 2, sorry, in group 0, so outside of the groups. In group 1, we've got 5, 6, and in group 2, we've got 101. So let's change these a bit and see if we can keep having matches. So yep, there's still a match if I change this to 4, 7. Let's see what happens if I change it to 3, 7. Okay, now we don't have a match because it's not one of those options. So another thing is we can do 5, 6 because it's one of those options, but we've got that quantifier, so it's between 0 and 1 times. So if we've got another 5, 6, oh, we don't have a match because the quantifier is the group those 0 or 1 times. So because of that quantifier, what we can do is we can just delete that because, oh, okay, well that's different than what I was expecting. I was thinking we could just leave that section out. And I think we can actually, yeah. So you can see they're a little bit, they're kind of thinking of it a little bit wrong, because they're saying that, oh, you can leave this out, but the problem is when it's left out, it's likely going to look like this, which doesn't have a match. But they're going to need to include a space in this 0 or 1, because when it's left out, it's as they have it now, there's going to be 2 spaces. So it's kind of not correct. I think a better way to do it would be let's see here. Would be like this, and then taking out this space here. Yeah, and now you can see there's still a match when it's missing because we're including that. And then if I add this back in and do a space, yep, we still got a match. So I think that's a better way to do that, because if you don't have these there, and that's the purpose of this quantifier there, to allow for that field to be missing, you'll still get a match because you won't have that the fact of there being 2 spaces won't prevent you from having a match. Okay, so yeah, let's see how this one's different now, because that quantifier is 0 and unlimited times. So it's going to be similar where I can't just take it away and get a match because it's expecting an extra space. So again, they kind of messed it up. They'd be better off having their spaces here and then having no space before here. So now I do get a match, even though I don't have that. Now, another interesting thing is it's between 0 and unlimited times. So if I just do 787878 unlimited times. Oops, but here's a problem where I can't do it this way. So it's kind of tricky. I need to figure out how this is a valid regex. Unfortunately, the example they gave is not. Okay, and I'm serious about ending it. I do need to go take a quick walk because I'm just not feeling super well, and I think that'll help me. And then, of course, I need to get back to my job at 1. So let's mark this complete. I think I've got a sense of it. I understand how regexes work enough to be confident doing this. And I appear to understand them better than the example does. So feeling pretty good about that. So I'm going to mark this as 1 done. And I'll see you in the after work video. Hopefully, if I'm just not feeling it, it'll be the lunchtime video, and then hopefully I can make it up during the weekend. But I'll see you then for route distribution. So thanks for watching, and I'll see you in the next one.